Welcome to Chapter 6. We're going to talk about arrays in this chapter. So you might have heard the term array before, but maybe some of you don't really know what it's about. Well, basically an array is an index collection or list of variables. It's just as simple as that. It just keeps it's just a list of things that you want to have stored. All elements of the array must be the same type. So if you wanted to make an array of integers, whole numbers, only whole numbers can exist in this imaginary list that we're talking about right now. Another quick thing are arrays count from 0. You'll see what that means in a second, but know that the first item in your list is cataloged as item 0. And we use these straight brackets to denote indexes, which basically denotes the arrays here. Here's an example of how we can initialize and declare some arrays. You'll notice this is an example. We start out by describing its type, integer, and then we give the open and closed brackets, and we give our array a name. In this case, we're going to call this array my int array. And then if we want to initialize it and give it some variables to hold, we do equals, and we do a new, another type of int, brackets again, and then notice the curly brackets. And 1, 2, and 4 are the 3 integers we're going to store in this array. So my int array will hold the values 1, 2, and 4. All right, same thing with strings, except instead of integers, we use the type of string, and we use quotation marks to say that we want to store these characters. If you want to access or initialize a single array element, you would bring up the name of your array. In this case, we'll just have a simple name of my array, bracket 2. What does that mean? Well, in this case, we're going to look at the third item in our array. So if we go back up to my int array, our third item is number 4. Well, we can set this number 4 value equal to 10. So this bracket denotes what place in the array you're trying to get at. All right. Here's some keywords that you may want to use. New, we saw earlier, right here. Basically means we want to allocate some new memory or some memory for our array to hold our variables. And we have the null keyword. Null basically just resets your array back to 0 with nothing assigned to it. So now that we've kind of talked about arrays, let's see them in action real quick. I went ahead and I've downloaded Chapter 6 assets. So if you haven't done that, pause the video and go and download them. Create a new project for Chapter 6. Import that package, Chapter 6 asset package in here, because I'm going to start using some examples of arrays, and you can get to those examples if you go to the prototype folder and you load example scene. So in this example, I have 4 different uses of arrays that are really basic to help us wrap our heads around it. All 4 of my scripts are attached to the main camera, as we can see here. So I'm going to go ahead and just uncheck these scripts so we can just look at one at a time. I'm going to go ahead and recheck array example 1, and why don't I double click array example 1, and we can bring it up in MonoDevelop and see what's going on. Alright, so we're here in MonoDevelop, and I'll walk us through the code real quickly. The first thing we're going to do is we're going to declare my int array. So just like usual, public int, just like any kind of int variable. The difference is we include these 2 brackets right here. And they're on the same button as our curly brackets we've been using for pretty much everything else. And then we're going to give my new array a name, which is my int array. And we're going to go ahead and assign it some values. We're going to initialize it. So we do equals new. Notice the new is in a lighter blue color. And then we're going to retype the type of array we have. So an integer, we're going to redo those brackets just because we're using an array again. And then we have those curly brackets, and we have values 1, 2, and 4 being stored in my array. So basically, if we had an array, we'd have a list just like this. This is all our array is holding, these integers right here. I'll go ahead and delete that. So now we have an array with these values plugged into it, and we're going to do some quick debug.logs to access and print these values. Alright, so I have a simple sentence, the first entry in the array, and then the plus symbol, and then to get at those values, we're going to call the name of my array, which is my int array, as you can see right here. And then we're going to do our brackets here. And since I'm trying to get at the first entry in my array, inside this bracket, I'm going to use the number 0. That dictates that we're starting at the very first entry in my array, which is 1. And just to make things quickly, show things real quickly, I just copy and pasted the first thing, changed some things, and now we're going to print the second entry. And notice the second entry is 1, denoted by 1 in that bracket. And the third entry denoted by 2 in that bracket. Alright, so if we press start, we should see 3 sentences that give us 1, 2, and 4 as our values. So let's see what happens in our console window right here. I'm going to press play, and there we go. The first entry in the array is 1. The second entry is 2. The third entry is 4. Alright, I'm going to unplay that. Notice how I have a update, some update code going. Basically, I wanted to show that you can access your array. So every time we press left mouse click, mouse 0 right here, we're going to access my int array at position, the first position in the array. That's what this bracket means. We want to look at my int array. We want to look at its first position, which is 1. And this plus plus is our increment operator. And it's just going to add 1 to our first entry. So if you press mouse button 1, plus plus, it turns into 2. Likewise, if I press the right mouse button, let's see what kind of code I have here. I'm going to take the value of the first entry in my array. I'm going to set it equal to the first entry again, plus the third entry, denoted by that number 2 at this bracket here. So if I pressed start and press right mouse button, it would add the first value and the third value together, and my new value would be 5. So let's see that in action. I'm going to clear the console. I'm going to left click, and we have the first entry in the array's new value is 2. I'm going to left click again, 3, 4, 5. I'm just adding by 1 every time I click the left mouse button, as denoted by this line of code right here. So what happens if I press the right mouse button now? Well, the next value in my array is 4. So if I right click, I now add 4 and 5 together to get 9. It's just some basic math, and we're showing how we can access the different entries in my array. Here's something cool that you can note. If I click on my main camera, which houses my example 1 script that we're looking at, notice how we have my int array here. And if I press the triangle, it's even got a drop down menu, and guess what? It shows us the length or the size of my array, and it shows what every value is stored in my array. So we have a clear representation, visual representation of what my array actually looks like right in my inspector. So I'm going to left click again, and notice how element 0 changes. We get 10. If I right click, it'll take the third element, which is denoted by element 2, and it adds it to the first element, denoted by element 0. That's just the name. I get 14, 18, 22. All right, so that's basically how arrays work. Let's see some other examples so we can just get more comfortable with them real quickly. I'm going to close that without saving. I'm going to pause this. Now I'm going to go back to my main camera. I'm going to uncheck my example 1. I'm going to check example 2. And let's look at the code real quickly. Right here you can see I just have an example of a string array. And I'm just quickly going to go over how we initialize a string array. It's very much like the first example. The only difference is we use those quotation marks, and we can store all these different colors, names of colors in my array. And I just have some quick debug.log messages printing out every color in my array. And notice we start at 0 again and go all the way to 5. Since there's 6 colors, I only need to print up to index 5 right there. Alright, I'm going to select my main camera. I'm going to expand my string array, and instantly you can see that my array is loaded up with all the colors. If I press play, the debug.log message prints out every name of the colors I've stored right there. Alright. So one thing you might have noticed is it can be pretty repetitive to have to keep printing out these debug.logs. I don't know if I've said it before, but anytime you have to type the same thing more than once or do the same thing more than once, there's usually an easier and more effective way of doing that. Right here, I'm printing 6 different lines using the debug.log and just changing up a few different things here. It wastes a lot of time, it wastes a lot of lines of code. So how can we probably do that a little bit better? All right, I'll show us an example 3 right here. All right, and you'll notice that it's still the same color string array. But if I double click on array example 3, I'll get the same kind of output, but using a for loop to do all the heavy lifting for me. So I'm going to go ahead and play this. If you don't believe me, we can see what happens here. We'll clear this console, and boom. Element 0 is blue, as you can see right here. Element 1 is red, and vice versa. So how does that work? How is this for loop printing this out so eloquently, so effectively? Well, the beautiful thing about for loops and arrays is that for loops have that counter built right into them, remember? That int I. Every time we go through the loop, I gets added by 1. Notice anything similar about how we go through our array versus how we go through our for loop? Well, if we look at my code right here, in my debug.log, I simply have element. Let me rearrange some windows real quickly so we can compare my console to what's going on here. All right. We print out the word element, which we can see right here. Then we do a plus, and we print out the counter integer right here, the counter variable that we declared right here. Notice how, since we start at 0, it prints out a 0. Guess what also starts at 0? Exactly, arrays do. So element 0, and then we have a few more characters we type right here. And then we print out my string array, and instead of putting a number here, the index that we want to access, which place in the array we want to access here, we simply just put my counter variable right here again. And since my string array starts at 0, and we declare I to be 0, I, the first time through the loop, is my string array 0. Okay? But instead, so we don't have to keep typing debug.log so many times, we'll just go through the loop. I will get added by 1. And the second time we go through the loop, my string array will equal 1. which accesses the second entry in my array. So our counter variable is doing a lot of heavy lifting here for us. And we get the same kind of output of code, vastly fewer lines than what you see right here. All right, so for loops and arrays go together like, I don't know, chocolate and champagne, I guess, wine and cheese. I'll try to avoid the peas and carrots metaphor. So let's look at one more example. Close without saving. And let's see what these cubes are doing in my scene real quickly. Why do I have those in here? So I'll deactivate script 3. And notice that every component within your inspector has the ability to be unchecked, meaning we're just going to get rid of it. You can do this for Unity built-in components as well as custom scripts we add to our game objects. So I'm going to go ahead and activate script 4. And you'll notice I have 4 cubes here. Cube A, B, C, and D. Okay? So I'm going to now make an array that stores every single cube in this scene into an array. Alright, that'll be useful throughout the lesson, you'll see here. But first, before I tell you why it's useful, I'm going to show us how we can do it. So I'm going to clear here. I'm going to open up example 4. And let's see what we got going on right here. Alright, the first thing that's a little bit different than the previous 3 examples is that instead of integers or strings, we want to make a list of game objects. Remember, anything in the hierarchy here is considered a game object. So we want to store these 4 cubes, all 4 of our game objects. So we declare it as type game object. And we want to do the array, so don't forget your open and close brackets. And let's give it a name, and let's call it my cube array. Notice how I haven't initialized it or given it any values. I'm just declaring that it exists right here. All right. This variable here is just a cube counter that we're going to use later on in the code. I'll come back to why I declared it in a second. All right, so to show us how we can get our cube to update in real time or propagate, I'm going to do an if statement where whenever I press the left mouse key, my cube array is going to get loaded up with all the cubes we have in my hierarchy and in my scene right here. All right. So how does that work? Well, with the beauty of GameObjects.find game objects with tag. Remember that function we used last few chapters to find all the asteroids to help with collision detection? Well, it's going to come in handy again. And we're going to, since we already have a hazard tag in my scene here, we're going to say that all these cubes are hazards. So since this is already denoted as an array here, and since we're finding objects with an S here, be careful because find game object with tag is something that'll pop up. We want to find game objects, plural there. So basically this is going to find every single cube in my scene with the tag of hazard, and it's going to inject it into a list for me. All right. So if I'm also going to have a for loop that gives the name of my current cube in my array. So hopefully when we press the left mouse button, then my list will fill up with all the cubes and it'll print the name of every single cube in my array. So this line of code is kind of like what we did in example 3 to go through a for loop to print every single value or every single color name in my array for me. So I'm going to hit play there, and I want you to, or I'll unplay it, and I'll activate example 4 again. And I want you to take a look at my cube array right here. Notice how it doesn't have anything in it, but these already do. All right, that's because we haven't field on our array up yet because it's in a update function that relies on us pressing the left mouse button right here. Alright. So I'm going to press play. Alright, nothing's happened yet. Keep your eye right here in my inspector as I press the left mouse button. And boom. When I press the left mouse button, every single cube in here gets put into my list, and we print out all the names of my array right here. We're not going to focus on sorting my array so it's in alphabetical order. We really just want to be able to put them in the list so in the future we can compare different values in, say, maybe an asteroid field to find the closest asteroid to the player or the furthest asteroid to the player. It's a little bit of foreshadowing there. There's one more thing I want to talk about with these examples, and let's revisit that for loop again. I've already talked about how the counter, I right here, allows us to access the many different entries in my array, or the elements that you see here. But what about this line of code right here? Well, if you haven't already guessed it, myCubeArray.length goes ahead and it tells Unity that we're going to go through this for loop 4 times because my size or my length is 4. So this is the compare here. This is what tells a for loop how many times to exactly go through my array, because length gives us the exact number of entries in the array. So that's how we can go through my array and get everything printed out with this debug.log message. Alright, so let's do something to manipulate this array. Alright, what if I wanted to destroy cubes every time I right clicked? Okay, you'll notice that I have a cube count here in brackets. Just another example of how we can use variables to denote what part of the array we want to access. So if I press the right mouse button, my cube count will start at 0, right there. So we're going to destroy my cube array at placeholder 0. So if I press the right mouse button, the first entry in my array should be destroyed. Alright, so let's run this again. I'm going to left click to propagate my array. So we have all my cubes there. So if I press the right mouse button, and if I click on cube A right here in my inspector, guess what? It highlights which game object over here on my hierarchy that element 1 is filled with. So if I press the right mouse button, then cube A right here should disappear and be destroyed. Boom, destroyed it. Notice how my array doesn't shrink in size. It simply is missing this game object now. So if you try to access element 0 or the first entry in my array, nothing would be there and you would get some errors. So keep that in mind. My code also has an incrementer. So every time I destroy a cube, my cube count goes up by 1. So if I press the right mouse button again, cube count will now equal 1, which is element 1. And I should now destroy cube D, which is at the bottom here. And boom, there it goes. What's the next cube to get destroyed? Anybody predict? Is it cube B or C that will be destroyed next? Well, if you've been paying attention, you can probably go to my array right here and guess that the third element, or element 2, the third entry, cube B, is next in line to be destroyed. And we have cube C here, and boom, it's done too. Alright, and notice how when I press unpause, unplay the scene, all my cubes come back, and we're back where we were. Alright, so those are some 4 examples of how arrays work for us. Alright, the next part of the video is going to go over some practical uses in relation to the space shooter game we've been working on. So I'm going to go ahead and go to Scenes and go to Solution. Let's not save that scene. And right now, We basically are beginning where we left off from the last chapter. So I press play. I have a single shot bullet here with left mouse click, and I have waves of asteroids spawning. And if I press the right mouse button, we get a burst fire. The burst fire was the assignment we had to do last chapter. So now that I already got that set up, I'm ready to begin work on chapter 6. In this chapter, we're going to create 2 more types of weapons in this game. We're going to create a orbital strike, or rather, I guess since we're already in space, we're going to use kind of a backup ship to come and blast a laser. We're going to blast the farthest asteroid from the player, and you're going to use that same game logic to figure out how we can also create a homing missile that tracks down the closest asteroid and blows it up. Alright, so how do we get started with this? Alright. So the first thing we're going to do is we're going to make a laser prefab. Just like how we have a bullet prefab that has a mover script on it, a collider on it with a trigger, and a rigid body. We're going to create a laser prefab that has the same kind of treatment. So I'm going to go over here. I'm going to minimize my game scene. Let's bring my console over. And let's get started making my laser. I'll just move my ship up real quickly. So we're going to go to 3D Objects, and let's make a cylinder. Alright. So we get this big chunky cylinder. It doesn't look quite like a laser, does it? Well, why don't we shrink it down? Let's just, you know what? I don't want to make a cylinder. Why don't we make a sphere? I think that'll work better. That way when we scale it down to make it look like a laser beam, we won't have that weird sphere stuff going on. But you know what? Again, so right now I'm going through the process of how best to describe my laser prefab. You know what though? If I had a skinny laser like this, look at this huge collision box. This laser is going to take out everything around that. No, that's not good at all. So yeah, why don't we bring that cylinder back for us? And maybe we can turn it on its side. Why don't we do a 90 degrees? So now it's facing forward like this. And the the goal I want to make with this laser is I want there to be like an imaginary support ship back here. When you call in like an orbital strike, that it'll fly in off the screen from this direction, and it'll hit whatever asteroid is furthest from you. So as I'm making this prefab, I'm going to keep that in mind. Alright, and look, my collider box, this capsule collider that's described by this green cage right here, it's pretty much it's forming the actual physical boundaries of this laser here. I don't want the laser to be too big, just big enough to look like a huge shot from maybe like a big gunship. And that looks good. Let me just clean up these values real quick. That's 0.06, let's say 0.05, 1.7, 0.05. I want to reset some of these transform values. That would be very important. And I want to take a look at my collider box. If you ever wanted to edit the boundaries of your collider, there's a quick little way you can do it by clicking on Edit Collider. And then you can grab these green little squares and push and pull them to be exactly where you want them to be. So that's nice. So my collider looks like it's lining up pretty well with the actual model of my laser. And let's not forget to check the collider to be a trigger, because this is not going to physically run up against the wall or anything like that. We specifically want it to collide with other hazards so the collision detection can take place and it destroy our asteroids. Let's also tag it as a bullet, because technically this is just like another player shot that will hopefully destroy the asteroid with it. And what's the other things I need to do? Oh yeah, let's add a physics rigid body component here, and let's uncheck gravity. We're going to be using this rigid body physics component here to drive the translation or the movement of this laser. Lastly, I want to call this laser. And now I have the physical game object of my laser created. Now we got to worry about coding this thing to do a few things. Ultimately, we want this laser to find the farthest asteroid from our player positions, and we want the laser to track the farthest asteroid and hit straight at it and without failing to miss and just blow up that asteroid for us. We want to do it that coming from off screen, so boom, like boom. Notice how in the game menu, that's the kind of effect I want to have, like this laser just coming from off screen to boom, right into whatever the asteroid that you want to kill. Alright, so what I'm going to do now is I'm also going to go ahead and take this prefab and position it right behind my camera here. Just do like something like -20. And why don't I go ahead and drag and drop this prefab into my prefabs folder. Alright, let's go ahead and make a script for this laser. I'm going to call this laser mover, and I'm going to go ahead and drop it onto my laser in my scene. You'll notice that this laser here, though, it doesn't have the laser script because I've only attached the laser mover script to the object in the hierarchy. See how we have it right here? But if we go to this prefab right here and hit apply, it'll update my laser prefab down here in the folder. So now my prefab has laser mover script. And I'm going to go ahead and get this out of my scene. Alright, the next thing we want to do is let's edit my player fire script. Remember, this is the script that we use to fire bullets. And let's make another entry. Let's say if input.get key down, right there, key code, and let's say spacebar. Let's use my spacebar to shoot this laser. Create my curly brackets. Get rid of that auto formatting. So right here, we just want to, just like the bullet, we just want to instantiate a laser. We want to instantiate my laser prefab. But don't forget, we have to make a game object variable so we can plug that laser prefab into my ship. So we've done public game object laser. We've declared this public variable right here, and we have a new if statement that checks for us pressing the spacebar, and we're just simply going to instantiate this laser prefab. So let's go to my medium fighter. You'll now notice I have a bullet right here and a laser. We have my bullet prefab plugged in here, but we don't have my laser prefab plugged in yet. So let's navigate to my prefabs. We can drag and drop it right on there, or I can press this little circle right here, and there's my laser prefab right there. So now whenever we press the space bar, we're going to instantiate this laser prefab. So let's see what happens whenever we press play now. Alright, there's all my asteroids. Boom. Notice how we now have this laser that was instantiated, but since we don't have any code on the script right here, all it does is just appear out of nowhere. So let's go through the task of using arrays to find out the closest asteroid to the player, or the furthest in this case. And right now you can already see what the furthest asteroid is, and it's this guy right here, this clone. And notice how they all have the same name? That's why we need an array here. We need to plug in all these clones into the array and treat them as separate game objects in the scene, so we can compare the distance between this asteroid and the player to this asteroid to the player to this asteroid to the player, and finally this asteroid to the player. Yeah, we need to go and solve for all the distances of these asteroids here, because Unity doesn't quite know what we exactly want to do. So we just have to go through the task of measuring each asteroid for Unity, and we'll write some code to say, yeah, this asteroid is not the furthest, this is. So that's basically what we want to do right now. Alright, but before we do that, let's get my laser just at least moving to the camera, or towards the player. So I'm going to bring up my laser mover. Here we have that. Alright, and why don't we bring up my bullet mover so we can have a nice frame of reference for how we got my bullets to move. And let's just compare these two scripts. I can see that I need to have a laser speed and a laser lifetime. So why don't we go ahead and set those public variables up. Public game, not game object. We want to make these floats. Floats laser speed and public float laser lifetime. So there we go. We have speed and lifetime. Let's go ahead and initialize these values. I want to make this laser travel really fast. And since it's going pretty fast, it's not going to, if it misses, it's not going to last for very long. 3 seconds will be its lifetime. So what else do we have? Well, in our bullet, we have a game object shot spawn, which gave us the position of where we wanted the shot to spawn from. Well, we don't really need to worry about where our laser is going to spawn from, since we already have it positioned out here. But we do need to have a game object that finds the position of the player right here. So why don't we rename this, call this public game object player position. And we'll just leave it blank for right now. So why don't we kind of use this? Well, no, we don't need to do that yet. But we do need to give that player position. We need to initialize that. So why don't I copy and paste that code? But notice shot spawns in red. That's because we're not doing shot spawn. We just need to have the player position. And we're going to use a GameObject.find, which literally finds the exact name of our player, which is called Medium Fighter. So when we instantiate our laser, we now have player position of the player instantly. That'll be useful whenever we need to start comparing the position of my player to the distance of the next asteroid that we're going to be solving for. Alright, so let's see, void update. Here we have this line of code right here. Why don't we just copy and paste it? Control C to copy. And it was an update. There we go. Oh, bullet speed's in red. Well, transform.translate. That's not really using our rigid body physics. Remember when we had our player mover script updated? We used our rigid body to get it moving? Why don't we bring up my player mover and see what kind of code we had there. Oh, we used a rigid body.velocity right there. Okay. So I'm going to use that same kind of principle here. I'm going to get rid of this. I'm going to write rigid body.velocity equal to vector 3 dot forward times my laser speed. Alright, basically what this is saying is it's using physics to drive the velocity of my object, and we're going to use our vector 3 functions that we've used before to drive the motion forward, to update the XYZ coordinates forward. I'll hit Control S, and hopefully what I should see is my laser instantiating from right here and flying in towards my player. So I'll hit play, and boom. Oops. There we go. Looking pretty cool, huh? Well, it's not really doing much. I mean, it's flying forward, but we can't hit anything with it. We don't have any targeting systems applied to it. Oh, there we go. My laser just killed those asteroids. It was a lucky shot, right? So now we need to figure out how we can get this laser, whenever it's instantiated, to create an array of all the asteroids on screen and compare all their positions to our player. I was hit the play right here. We have, or pause, we have all these asteroids on the screen that we need to find the distance to the player. Alright, so how are we going to do that? Alright, I'm going to get rid of some of these other scripts, and we're mainly just going to focus on our laser mover. Our laser mover script is what's going to find all the positions of the asteroids and target the furthest one. So let's just keep it simple. We'll do it one step at a time. Let's just start by creating an array of every single asteroid on the screen at the time that the laser was fired. Since our player fire instantiates the laser whenever the spacebar is pressed, for all intents and purposes, this code doesn't exist until we press the spacebar. So at the very beginning of this code, we can use this. We can write what we need to in start. The start will be the exact moment in which we press the spacebar in our game. So we need to create an array of all the asteroids on the screen. So why don't we go ahead and declare an array. We're going to do a public game object. We're going to do the brackets there, and we're going to call this hazard array. Notice how similar it is to our player position variable. The only difference is we have these brackets, right? So now we want to assign my array here all the asteroids in the scene. Just a list of every single asteroid in there. So let's just say hazard array equals, and we're going to use that game objects, find objects with tag. Notice how it's objects, plural with an S. And we want to find all the hazards on the screen. So whenever my laser is created, that's all the lines of code we need. Just two. One right here to declare it. Another line right here to initialize it. I'll hit Control S. And let's see what happens to my laser now. So you want to hit play. Let's get a few asteroids on the scene. Let's get 2 waves spawned. Actually, maybe let's not die this time. I'll keep my eye on the game screen real quickly. Alright. So I'm going to hit the spacebar and pause. And see what happens. Nothing in my array got... Okay, something's wrong here. I have an error right here. Tag hazards is not defined. You know what? I made hazard plural instead of singular. There's the syntax error right there. So easy to do that, isn't it? So I'm going to play the game again. And I'll press spacebar. And now, look at this. My hazard array. There's 9 different asteroids at play here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you'll notice, let me select my laser clone again. That's where the array is housed under my laser mover. You'll notice if I click on the actual asteroids in here, it can tell the difference between every single clone in my hierarchy. So even though they're named the same thing, the array knows the difference between each single one. So now we have an array where we can specifically point out each asteroid on screen. So now we're one step closer to figuring out the distance between the asteroid and the player. So what's next? Well, the big one. We need to figure out how we can get this measured, this distance measured between each asteroid. So what kind of logic do we need here? Well, we need to measure the distance from the hazard to the player. We need to compare these distances among each hazard on screen, and we need to create a target that is the furthest from the player. So why don't we create and use a for loop that compares the distance of each asteroid that's in our list. All right, let's do that. And we're just going to do it right here in start. That's all we need to do. So I said we need to create a for loop. Let's say for int I equals 0. And then as long as I is less than, what are we going to do it in? How about the size of my array? All right. And then we're going to use my incrementer. And there's my awesome for loop that's going to do all the heavy lifting for us. All right. So the current hazard we want to measure equals to the hazard that corresponds to the counter in my for loop here. So the first time through the for loop, since it's set to 0, we're going to do all this code. We're going to measure the distance of this asteroid. And if we do my laser here, element 0 is going to be this cloned asteroid right there. So we're going to measure the distance from this asteroid to the player's position. Let's do it. So in our for loop, we need to declare a game object that can hold the value of this asteroid. Just a temporary game object variable. So why don't we call it game object, and then let's call it something literal like hazard being measured. All right. And then what we're going to do here is we're going to say the hazard being measured equals to hazard array bracket dot game object. So we don't have to keep typing out hazard array i.game object. We're going to go ahead and set that to the hazard being measured, which corresponds to the counter here, which starts at 0, which corresponds to element 0 in our array. So now we have a game object that has grabbed which asteroid we want to measure. Next, we need to use a vector 3 coordinate system that describes the distance between the player position to the asteroid being measured. So that's a mouthful, but just follow along with me and I can show you what I mean. All right, the next thing we're going to do is we're going to declare a vector 3 variable. And let's see, why don't we call it, let's call it my measured distance. Let's see. All right, so we have a public variable for the distance between the two objects. We need to make another game object. Well, we already have a player position, so do we need to have another one? No, we have what we need. We have the position of the player, and we have our object that we need to measure. So let's create the math that does that for us. So let's say current distance. We don't have a current distance yet. But we need to find the current distance. So let's just go ahead and say that we want our current distance to equal hazard being measured. We want its position, so we'll go transform dot position. minus player's position. So let's do player position dot transform dot position. This current distance doesn't really make sense. How do we create a variable that holds this value? Well, we can't exactly do the current distance yet. We need to actually say measured distance. This is going to give us the difference between the x, y, and z coordinates of the hazard being measured and the player's position. Alright. So we have an XYZ value of the measured distance between my first asteroid and the player's position. But that's going to be kind of hard to quantify in terms of numbers. Well, here's a nice little function that we can use to turn this vector 3 value into a nice float that we can use to measure distances with, or compare distances with. So why don't we create a new variable up here. Let's call it public float, and let's call this the current distance between my objects. And we'll just do current distance equals measured distance dot, since this is a vector 3 variable, we have a function we can called square magnitude, which takes those x, y, z coordinates and lets us convert it to a nice float. And this nice float will be the value we use to compare the distances between all the asteroids. So basically what we did, we just found the x, y, z coordinates of the player and the asteroid we're solving for. We figured out the difference between those two positions, and we turned those x, y, z coordinates into a nice float value. Alright, so that's one little thing out of the way. Now we need to have an if statement that compares the distances from the last asteroid that we solved for to the current asteroid we solved for. Because remember, we're having to go through every single asteroid in our list. And there's a nice little way we can do it. We just say if current distance is less than the last distance we had. Let's call it old distance. And I haven't declared that variable yet. So why don't I do that? Let's have just a public float old distance. So this float value is basically a placeholder that we use to hold the distance we measured from the last time we went through our loop. It's a little weird to wrap your heads around, but just keep following around with me and you'll see why we have two placeholders for distances. So let's just say we're our first time through our loop right here. And we found out that, what asteroid are we solving for? Element 0. This asteroid right here, we've found its position in space. We've found the player's position in place. We've compared or subtracted the distance between these x, y right here, the x, y, and z coordinate positions between the two. Now we have a float value that describes this position to this position, exactly how far away these 2 points are. Since we're going through our loop for the first time, we don't have a value for old distance yet. Since it's brand new, it's going to be set to 0. So if our current distance that we just solved for is less than old distance, that doesn't make sense. If it's greater than our old distance, because we only want to do the next bits of code if we found an asteroid that has a larger distance than the last asteroid we solved for. So let's just do a few things, 2 lines of code. We need to set a new target variable. Why don't we make a new public variable, a new game object, and let's call this the furthest hazard. Alright. So how did I spell that? Let's just copy and paste just so there's no syntax errors. The furthest asteroid will now equal the hazard being measured, because this hazard that we just measured is now the farthest asteroid we have in our loop so far. And we want to take our old distance, we want to make it the new winner, the new champion, which is our current distance. So the next time we come through our for loop, our old distance will be like, you know what? I have the asteroid that's the furthest from the player right now so far, and I'm going to be used to measure against this new distance we found in the asteroids. Alright, now I'll hit Control S to save, and we should be able to solve for the furthest asteroid here. And if you don't believe me, then I'll show you guys. Alright, so let's press play. Great, we got no syntax errors. I've already destroyed one asteroid. We have some new ones here. I'll press the spacebar and pause it. So now all that code should have worked for us. So let's look at our public variables here. Furthest hazard should have already been solved for because we went through our for loop 9 times. We checked every single one of these asteroids. We compared their distance to the last asteroid. And the beauty of this code is, if we find an asteroid whose distance is shorter, then we just skip this code right here, and we don't even worry about that asteroid anymore. We just completely skip over it, and we just go on to the next asteroid in our array. So the big question is, the furthest hazard should have already been solved for. So what is the furthest asteroid in this game scene, real quickly? Well, I think it's this one right here. I think it's this very far left one right here. So let's see. Maybe when I touched that asteroid, it got rid of that value here. Let's try it again. Normally that wouldn't happen in the game. So we're going here. This time I won't select the asteroid. I'll press spacebar. Still hasn't done it. Alright, so I did some debugging. I figured out why we weren't getting a value in my furthest hazard. And this is a dumb mistake. It's because I initialized the array in the update function right here. So I'm going to cut and paste and put it right here in the start function. We only want to populate the hazard one time for that moment in time in which we press the spacebar. So I don't know why I put it down there in the update. That was just totally wrong. Well, just an example of debugging on the fly, I guess. There we go. So now, hopefully, whenever I press play, when I shoot my laser, it'll have solved for the furthest asteroid. I hit spacebar. There we have my laser right there. And success. My furthest asteroid now has a value assigned to it. If I click on it, let's take bets. Do you think it's this asteroid or maybe this asteroid? I'll click it. It highlights the asteroid in the field. And it's actually this asteroid. Alright. So now that my laser has found the furthest asteroid, I need to figure out a way where I can get my asteroid to fly straight to that target. I've already found out the furthest asteroid. Now I just need to get it to fly straight at it. Well, that's relatively easy. We're going to just use 2 lines of code, and it's going to be in the update function here. Why don't we just get rid of this old code, because this is the code that gets it to fly straight to the left towards the player. Why don't we say game object, meaning the laser that the script is attached to. It's transform dot look at. This look at is a new function that's part of the transform class right here. And basically it needs a target to look at. So let's just say furthest hazard, and we need it to look at its position, so we'll call its transform.position. And basically what this line of code does is it rotates and orientates my laser prefab to look exactly at its target, which is the furthest hazard right here, for every single frame that passes by. So let's hit Control S and see what happens here. So I'll back up a little bit, and we can see when my laser spawns here, we'll see what happens. Notice how we have the asteroid, or the laser, and some kind of weird orientation. It's because it's trying to look directly at whatever asteroid it's targeting. So why don't we write some lines of code that get the laser to actually travel to it. We have rigid body.velocity, just like last time. But this time we need to get the velocity to travel, or rather to get pushed. So let's use a transform. That's a new little line of code here. Direction. We want the velocity to travel along the transform direction, basically the way that the object is looking. All right, and let's do a vector 3.forward, just like last time, times our laser speed. Now I have a feeling that something's going to go wrong here, but if it doesn't, I'm a genius. If it does, we're going to figure out what's going to go wrong together. Alright, so I'll hit play. I'll get some asteroids coming on the scene, and boom. Well, that's brilliant. My laser's flying at the asteroids, but what in the hell? It's not, that does not look like any kind of laser I've seen. Basically what's going on is the orientation of my prefab is not jiving well with the look at function we used right here. You could probably have saw that whenever I first instantiated my laser before it flew somewhere. It was pointed at a really weird angle. So what's going on here? Well, as you can see, we go to my local. See this little Z arrow right here? That is the object's forward direction. I change this between global and local by doing so. If I did a global right here, then Z is just straight back like always. But if I go to its local coordinates, then we can see this object's Z is in this direction. And whenever I call vector 3 forward, well, since it's going to go forward, it's not going to do this. This is the kind of the effect that we wanted, right? Well, look which way forward is pointing now. It'd be going down. So there's two fixes to this. One's quick, and the other one's not so quick. Let's try the quick one. Well, if this direction is up, if Y is up, looks like we need to travel down the up way. Maybe this won't work at all, but let's just see. Maybe let's change forward to up. And we'll hit Control S. Let's see what happens now. Nothing happened. Whoa. That's not what's going to happen. See, what the deal is that, let's bring back our thing again. Let's bring back our game. And let's shoot a laser. Alright, let's shoot a laser. Basically, we've told this thing to travel up while always look forward to our target, which is this guy right here. So we got a conflict of interest. It wants to look that way, but it's being told to travel this way. So the problem really does lie in the way we set up our prefab. So why don't we go back and make a change to our prefab real quick so we can get our laser going just right. So what I'm going to do is I'm going to bring my laser back into my scene here. And we already see a few problems here, right? If look at is always going to orientate my Z arrow right here, my forward direction, it's always going to rotate it towards its target, then the way this laser looks just isn't right at all. So let's reset some of its values and see what we can do to make it look right. Well, I'm going to be honest. The quickest way to do this is just rescale it. Make it a little thick. We've just rescaled it. So now when it's the long way, it's pointing in the Z direction. We need to check one. Oh, that looks crazy. Look at that big collision box now. That's not at all what describes the shape of my laser. So we're going to have to fix my capsule collider here. Let's crank down the radius. And maybe let's increase the height. Well, there we go. Well, now it's pointing just the wrong direction. We need to change its direction from the y-axis to, you guessed it, the z-axis. Now, I can press Edit Collider, grab one of these squares, and we can edit my collision box on my prefab to coincide with the new scale and direction of my prefab. So now that when we have the look at function right here, always pointing the blue z-axis at our target, and I can change this vector 3 up back to forward. Now everything should be fine. So we made a lot of changes to my laser. So don't forget to select the laser in your hierarchy, the current one we're working on, and go to Prefab, and let's update or apply the changes we just made to our laser prefab. Alright, great. So let's see what happens now. Boom. We got lasers taking out all kinds of asteroids. Alright, so what you just saw here is an error message we're not going to worry too much about. The object of type game object has been destroyed, but I'm still trying to access it. Well, that's because we have a lifetime on my asteroids here, right? And sometimes they'll get so far away from my player back here that their lifetime of, let's see, 10 seconds, it just goes up. But we've already shot my laser, let's say at its 9th second of its life. And then when the number 10 ticks around for its lifetime, it gets destroyed through its lifetime destroy code. But now I have this laser out in space, just flying with no target, and I get this error message. It doesn't crash the game, but it's definitely, a loose end. So why don't we do this? The problem seems to be that my asteroids, and why don't we speed up the speed of my asteroids, just so I can see what's going on. That doesn't matter. The problem is that the asteroids just keep going, no matter if they've gone off screen or not. Look how far back they go. They just get destroyed all the way back here. Why don't we do this? Why don't we make like an invisible bounding box right behind our game scene that catches all the asteroids that go off screen and goes ahead and destroys them. So that way we don't have our laser or other kind of homing weapons we want to create in the future chasing after objects that are just way off back in the distance here. So that's going to be a quick fix. We can just go to 3D object. We can just create a cube, and we can just size the cube up. Why don't we just make it a little thick like this? Basically, you just want to create a big back wall right here. We can make it a little bit bigger, and if we want to compare to where we need to position it, we can always use my ship here. I'm going to move my ship in my scene view, and some of you may have your game window right here. Well, you can just click and drag it and dock it right beside your scene view. I'm just going to take my ship right there, and this is about off screen. So now I can measure exactly where I may need to put my box. And since my box already has a box collider on it, let's make sure it's set to trigger. Well, you're probably saying this box is really ugly. Well, guess what? We can uncheck Mesh Renderer. Now all we're left with is just a nice big box collider, and we don't have to worry about that big white box in our game view. Why don't we set its tag to player? Because our asteroids are already set up to destroy themselves when they collide with objects with the tag of player. And let's just go ahead and try that out. I don't think we need to add a rigid body physics option there. We'll hit play, and let's see what happens. Boom. My asteroids go off screen. Oh, looks like they pass right through the box, though. I wonder why that is. Because the script is set to also destroy the player. So that might not work to our benefit. Looks like we might need to create a new tag. And let's call this boundary. Alright. And go ahead. I mean, I want you guys to do this too, so make sure you're doing this because this will only help your final game, which you'll be using at the end of the semester, or we'll be working on at the end of the semester. And we can call this cube the boundary tag, and we can just quickly update my collision script right here. And why don't we let's just do some quick copy and pasting, and we can edit it. We can get rid of that because we're only going to check for one thing, and let's say boundary. And let's get rid of that destroy other game object, because that's what destroyed my game boundary last time. We're just going to destroy the hazard itself. Hit Control S. Looks like we got a parsing error. Yep, I deleted one of the brackets. So we'll bring it back. Gotta love syntax. That looks good. So now we have my cube with the new tag of boundary. And now anytime that the asteroid hits something with the tag of boundary, it's only going to destroy itself. It's only going to destroy the hazard. And it's not going to destroy the other thing it collides with. So now my boundary, let's just go ahead and call this boundary, will always be there. And it's going to just boom, boom. All these things are just going to collide with it. Now I don't have asteroids going, or lasers chasing down asteroids from God knows where. Alright. I'm going to try not to just get destroyed so we can see what's going on here. So right now, the problem we're having is that my asteroids are moving too fast and my laser can't catch up with them. So I'm going to why don't I speed up my laser and slow down my asteroids. So right here, I'm just basically tweaking the various variables that I gave myself to get the exact type of functionality I want out of my new laser. It's all part of the process. I think they were set at 3 before. Boom. Look at these lasers just coming off the screen. My laser, I'm getting that fire support from my frigate off screen, destroying every asteroid that's the furthest away from me. And that's basically a process I've used. I've used arrays and clever use of for loops to find the distance of every single hazard in my array. And I've created a new type of weapon to use in my game just by some clever coding and some nice usage of if statements and for loops and arrays. So I've given you everything you needed to use to finish the assignment for this week, in that every time I press the middle mouse button on my mouse, I want a homing missile to launch from my fighter craft and hit the closest asteroid this time. So it's going to function like a bullet in that it's going to originate from the center of my plane, but I want it to track the closest asteroid right here and blow it up. It's almost the same code verbatim as the laser. Here are a few things you may need to solve for that you may not have had to worry about with the laser. And I'll go ahead and just point them out. Right here, we set old distance equal to 0 because the first time before we hit the loop, old distance needs to have a value. Well, since we're finding the furthest thing from the player, we wanted to start with a small number because that's just 0 is the smallest number you can use in this instance. But if we're finding the closest thing, what's the difference opposite of 0? Well, infinity. So we can set old distance equal to math f infinity. Basically what this is going to do is going to assign old distance to be the biggest number in existence, which is infinity. That way when you're going through your loop, it'll compare against the biggest number in the world. That way you have a clean starting point for your for loop. Alright, so that's one of the biggest differences you'll have to work out in your homing missile. Also, since we're having to worry about where the homing missile starts, you're going to have to worry about, just like in, let me bring up the bullet mover. You're going to have to worry about where the bullet spawns. So in this case, we have a shot spawn for the bullet, and we set its initial position to the shot spawn's position. So that's another consideration you'll have to think about for the missile. And really, everything after that is just maybe changing up the name of some of your variables, and then you're going to have to re-examine this if statement. But everything after that pretty much is the code verbatim. It's just setting up your weapon types. So if you follow this video, you should be well onto your way to making that homing missile. And I'm going to go ahead and bring up the solution and show you what that homing missile should look like in action. Be right back. Alright, so I got the solution loaded up here that I came up with. You'll notice a few things different in that we have a bullet, laser, and missile prefab attached to my player fire script. If I press the left mouse button, we get a single shot. I right click, I have my burst fire. I press spacebar, I get that laser shooting out my asteroids. But if I press the middle mouse button, I get a homing missile. I made it slow so you can see how it tracks my asteroids. I want you guys to create something just like it. Alright, so that's your goal for this week. If you have any questions, as always, please feel free to email me, and good luck.